Good morning, ladies and gentlemen. Your host, Golden Zulu. So today we have one interesting question which I haven't put the title. So I want us to read together to come up with where this question basically falls, but it is under probability. So this question is reading to say, on average, 2.5 customers per minute arrive at an airline check-in desk during the peak period. Assume that the distribution of arrival is Poisson. Find the probability that there will be at least 3 arrivals in a minute. So when we are dealing with probability, we need to understand to say that it is divided into so many subtopics, or rather units, where we need to understand one basic concept. Probability, you have what is referred to as the Bayes theorem, the Poisson distribution, the binomial distribution, conditional probability. There are a lot, but for this one they gave us this word Poisson, so which means that we are dealing with what is referred to as Poisson distribution. But in another video which I will create, I will look at a question where it is silent, but we will derive the term that is in there by using what are referred to as properties of each and every given subunit. Remember, when you are dealing with Poisson, it has certain kind of properties which you should know to say, oh, here you are dealing with a Poisson's question, here you are dealing with a binomial's question, so that we should know if maybe there are trials in there or not. So since we are dealing with what is referred to as a Poisson distribution, we need to understand to say that the Poisson's equation is given by exponent of E mu multiplied by mu to the power x over x factorial, where x is any number that is ranging from 0. So I will briefly explain on x, just giving a brief highlight. So when we are dealing with this x is simply the number of events occurring. So let us assume to say you are driving a car, then they have told you to say you should use the Lusaka road. So since you are using the Lusaka road, then they have told you to say you should count the number of potholes on the Lusaka road. What you will do, you cannot count the non-potholes. Why? Because the tarmac is so smooth. You can't count the non-potholes, but you can try by all means to count the potholes. So there are events in that you cannot calculate while calculating another. That's one characteristic, or rather property, of Poisson. So for you to get one thing, the other thing cannot be done. So you will calculate the number of potholes in that this number of potholes are present. You can be like, okay, here's a pothole 1, here's a pothole 2, here's a pothole 3, but you can't calculate the others. So like, let me give an example of a calculator. If I was to say calculate the number of buttons which are here, you will just go directly to calculate. But if I say calculate the non-buttons, even here, it is a non-button. But remember, here there are small atoms. So what I'm trying to say here is you can know the number of potholes and use the number of potholes to know the number of non-potholes. How do you know that? Remember, in probability, every probability is equal to 1. Then since every probability is equal to 1, and under binomial distribution, when we were dealing with binomial distribution, there is a formula which we wrote to say the number of success plus the number of failures is equal to 1. Then remember, the number of success in this case, I will represent it to be the number of potholes. Then this Q is the number of non-potholes which are there on the Lusaka road. So if I am to subtract the number of potholes from 1, definitely I will get the number of non-potholes. So there are some situations in that you need to know one event for you to depict another. Why? Because that other event which you have depicted cannot be calculated. So now that we have come across such kind of thinking in our question, remember they're telling us to calculate the probability that will be at least 3 find the probability that there will be at least 3 arrivals in a minute. So the first thing that you need to do when you have been given a Poisson question, remember at least simply means greater than or equal to. So let us say at least there will be at least 3 minutes. Let's say 3x, isn't it? Then they want at least 3, which means equal to 3 but greater than to positive infinite. Do you know the numbers in infinite? No, you don't. So this is where we'll base our earlier explanation. This is where our earlier explanation will come in. So remember this, they have said greater than or equal to 3. But greater, will you go to infinite? Will you write this repeatedly infinite times? Do you know where you are ending? Billion, trillion? Oh, there, we are going there. So now that you have known this kind of explanation, what am I trying to say? What I'm trying to say here is this. You will subtract 0, 1, and 2 from this one when you deal with the Poisson's formula, which means you have remained with numbers from 3 all the way to positive infinite. So let us now write this in mathematical language. So the probability that x is greater than or equal to 3 is equal to 1 minus, so we are getting the Poisson's formula now, where remember the events always, remember I said x is the number of event, but the number of event in this case will always start from 0. So the exponent, this mu is you to find it. So mu is equal to lambda times time. Remember what we discussed in our previous video under Poisson and binomial. So remember there is what is referred to as Poisson with binomial to limits. So remember this lambda, as it is in physics, represents the per volume and per output. So in this case, per output which we were given is 2.5. They have told us in a minute, and we have it in 1 minute, which still remains to be 2.5. So always remember that this lambda and the time, there should be always in the same units. So we have the first number of events to be 0. So we say negative 2.5 multiplied by 2.5, where the first number of events is 0 over 0 factorial plus e to the power negative 2.5 multiplied by 2.5 to the power 1 over 1 factorial plus e to the power negative 2.5 times 2.5 to the power 2 over 2 factorial. So if we were to remove these from 1, we will remain with numbers starting from 3 all the way to positive infinite. So here, remember any number to the power 0 is 1. So we are just having shift exponent negative 2.5, and we are getting our answer to be 0.082. Then also here, shift exponent negative 2.5. We are getting that multiplied by any number to the power 1 is that number. So in this case, times 2.5 divided by 1 factorial. 1 factorial, shift 1 factorial, we still get that. So we have 0.205 plus here 2.5 to the power 2 is 6.25 multiplied by open bracket, shift exponent negative 2.5. We are getting that divided by 2 factorial. We are getting that. So plus 0.257. Remember, we are subtracting from 1. This is the probability when x is greater than or equal to 3. So let us add 0.082 plus 0.205 plus 0.257. We are getting our answer to be 0.544. Then we subtract 1 minus the answer we are from getting, and our answer is 0.456. So this is the probability that there will be at least 3 arrivals in a minute. At least, which means greater than positive infinite. So this is the probability. Your host, Golden Zulu.